Hi girls, sorry to miss class today, but as I told you, I've made this video of just some more linear programming problems. So we'll hold off on checking your homework from last class until I get back, and we'll check them all together. So I'm going to show you a couple more examples and then assign you a couple examples that are similar to what we're doing. So do your best, and you should be able to complete the homework, and then we'll go over it next class. So this is a different type of problem that we're going to look at today, and these are actually called mixture problems. And what makes a mixture problem a little bit different is that we're trying to maximize or minimize profit again, but it's on a mixture of stuff or of ingredients, and so our constraints kind of have to do with ingredients. So anyway, just makes it a little more complicated, but also once you understand it, it seems actually kind of easier. So let's take a look. So suppose you make and sell skin lotion. A quart of regular skin lotion contains 2 cups oil and 1 cup cocoa butter. A quart of extra rich skin lotion contains 1 cup oil and 2 cups cocoa butter. You have only 24 cups oil and 18 cups cocoa butter. You will make a profit of $10 per quart on regular lotion and $8 per quart on extra rich lotion. How many quarts of each type of lotion should you make to maximize your profit? Okay, so what we're going to do here is first, just like we said last time, we're going to look at that main question, which is how many quarts of each type of lotion should you make to maximize your profit? From that statement, we know that our X and our Y are going to be the quarts of each type of lotion. So our X is going to equal regular skin lotion, and our Y is going to equal extra rich. I know these examples seem kind of corny, but extra rich skin lotion. Okay, so we got that because it's asking how many quarts of each type of lotion should you make to maximize your profit. So then we know that our objective function is going to be to maximize profit. So right now we can also make our objective function equation because we know it's based on profit of X and Y. So we're going to say, what is the profit that we make on X, which is regular skin lotion, and we make $10 a quart profit on regular skin lotion. So our profit equation is going to be 10X plus $8 a quart on extra rich, so plus 8Y. So now we've taken care of those numbers, so we're going to mark those X. We're not going to use those anymore. Okay? Now when it comes to constraints, if you look through this, again, there's a lot of words, and that tends to be confusing for people. But if you look through this, you can see that we're talking about oil and cocoa butter. Oil and cocoa butter. So our constraints is really how much oil and cocoa butter we have in order to make the lotions. So in these mixture problems, you can actually name your constraints, just like we named like the mom constraint and the pizza manager constraint. These constraints we can name oil and cocoa butter because we're not selling oil and cocoa butter, but the amounts we have dictate how much lotion we can make. So if we look at oil, we only have 24 cups oil. So we know no matter what oil we use, we have to be less than or equal to 24 cups, right? We cannot go over that. Now, we need oil for both regular and extra rich skin lotion. So regular skin lotion, so now our constraint on oil is going to take into account everywhere we see the word oil. So a quart of regular skin lotion contains 2 cups oil. So regular skin lotion, which is X, contains 2 cups oil. Extra rich skin lotion contains 1 cup oil. So the Y is 1 cup oil. So no matter how many quarts of regular skin lotion, we multiply it by 2 to see how much oil we need, and no matter how many quarts of extra rich, we multiply it by 1 to see how much oil we need. Okay? The next constraint is all about the cocoa butter. And it says we only have 18 cups of cocoa butter to use for both of them. So this constraint is going to be less than or equal to 18. So again, we need to find out how much cocoa butter does the regular need and the extra rich. Regular skin lotion contains 1 cup cocoa butter, so we're going to put a 1. And extra rich contains, contains 2 cups cocoa butter, so we're going to put a 2. So again, this constraint is mixing the regular and extra rich, but it's all about cocoa butter. Okay, so now that really takes care of everything. We've taken care of all the numbers. Okay, so now we are going to graph. So first we'll bring this down, and we've got 2x plus y less than or equal to 24. So let's put it in mx plus b. So we're just going to subtract. So we get y less than or equal to negative 2x plus 24. And then let's go ahead, and I'm going to go ahead and bring down the second one also and put it in mx plus b. So x plus 2y less than or equal to 18. So we subtract x, 2y less than or equal to negative x plus 18, divide by 2. Y is less than or equal to negative 1/2 x plus 9. Okay, so these are the two we're going to have to, we need to graph. And again, one of the challenges on linear programming is to pick your scale, because we only have a 20 by 20 here. So we're not going to just extend it by 4. We're going to pick a different scale. So we can have to go up 24 on this one and 9 on that one. So actually, we could go up by 3s, because they're both multiples of 3. So let's go ahead and do that. Let's go up by 3s. So I'm going to draw my axis here, and this is the x-axis, and it is regular skin lotion. And I'm going to draw my axis here. Bad. Still not great. And this is y, and this is extra rich lotion. So now I'm going to graph. So negative 2x plus 24. So when you use a scale, and over here I'm going to say that my scale is 1 box equals 2, or what did I say? No, equals 3. Okay? So when I graph this, I'm going to count by 3s. But if I'm going to let the y-axis count for 3s, I'm also going to let the x-axis count for 3s. So if I go up 3 to 24, I'm going up 8, right? So 3, 6, 9, 12, 15, 18, 21, 24. So I'm going up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm still going to keep my slope negative 2 over 1, because I'm going to let every box up the y-axis count for 3, and every box on the x-axis count for 3. So that way I can still count my slope normally. So down 2 over 1, down 2 over 1. So even though I'm really going down 6 over 3, it's still the same slope, so I'm okay. So I can graph that, and I'm going to shade underneath. Okay. So now I'm going to graph this one. I'm going to do this in green, just so it'll be clearer. So I'm going to graph this one. So I'm going to go up 9. So again, I'm still counting by 3s. So I'm going to go up 3, 6, 9. So I'm going up 3, down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. So I draw that line. It's kind of messy. And I'm going to shade below. And so that's one of my only constraints. Now, because of these are application problems, we can always assume that x has to be greater than 0 and y has to be greater than 0. So we're always in that first quadrant. So now our feasible region is this right here. Okay. So now we want to find our vertices. So our vertices are going to be right here. And again, since we know that is the y-intercept of the green line, so we know A is 0, 9. And right here, this is going to be B, but that is not actually on a good point, right? So, so we need to find out what that exact point is. So actually, what I'm going to do is I'm going to actually graph that. Because again, we can use any of our methods to, where's my calculator? Okay, actually I was looking for my calculator, but I decided to do it a little bit differently. So we need to find out where this is intersecting. And you can tell, because we're using a scale of 3, we can't really tell, because it is, this point B is in between the third and the fourth line and the first and the second. So here it's somewhere in between 9 and 12, and here it's somewhere in between 3 and 6. So we need to find out where it intersects. Well, we know from our quest we just took that we can use many methods to find out where these two lines intersect. So I'm going to quickly here just go ahead and make them equalities, because we're just trying to find the point where they meet. And I'm going to use elimination on them real quick, and that'll tell me where they meet, right? So up here I can multiply, I'm going to multiply this one by -2. Okay? So this becomes negative 4x minus 2y equals negative 48. And then when I add them together, this cancels out. I get negative 3x equals negative 30. Divide by negative 3, x equals 10. So I know that this point right here is 10, and then I have to find my y value. So I can come back up here, and if that's 10, if I plug in 10 into this equation, I get 2 times 10 plus y equals 24, which gives me 20 plus y equals 24. So I know that y equals 4. So this point down here is 10, 4. So my point, now you won't always have to do use another method, but sometimes you will. It really depends on your scale and the equations. So B is 10, 4, and C is actually, that's on a good point. So I want to use my scale. So 3, 6, 9, 12. So C is 12, 0. And if, yes, so 12, 0. So those are my 3 points. And now, those are my 3 vertices. Oh, and I've got a 4th one here. D is 0, 0. So now, to find my winner, I'm going to plug them into 10x plus 8y. So that was my objective function. So 10x, oh shoot, sorry, 10x plus 8y is my profit. So if I plug in A, I'm saying 10 times 0 plus 8 times 9 gives me 0 plus 72, gives me $72. B is 10 times 10 plus 8 times 4 equals 100 plus 32, so it gives me $132 profit. C is 10 times 12 plus 8 times 0 gives me 120 plus 0, so $120 profit. And D is 0, 0, so I know I'm not going to make any profit on that. So if I'm looking to maximize my profit, then the winner is the higher one, which is B. So if I were going to write that out, I would say to maximize my profits and make $132, I should make 10 quarts regular lotion and 4 quarts extra rich. Okay, so that is a mixture problem. So again, my constraints were about my ingredients, right? My products I'm making were the skin lotion, but my ingredients were my constraints because I only had so much oil and I only had so much cocoa butter. Okay? Now I want you to look at the next slide. I'm going to get you started on it, but it's going to be your homework. So here you're baking a tray of corn muffins with milk and flour, and you're baking a tray of bran muffins with milk and flour. You have 16 cups milk, 15 cups flour, and you're trying to make a profit. So here's what I'm going to set up for you guys. I want you to read. I'm not going to read it all to you because I want you to do it. Your variables are going to be, X is going to be corn muffins, Y can be bran muffins, okay? Your objective function is going to be profit, right? So you're going to have to find how much profit is in corn muffins and multiply that by X, and how much profit is in bran muffins. And then your constraints, you're going to have one constraint that's all about the milk. Okay, so you're going to have to set up how much milk X needs, how much milk Y needs, and that's going to have to be less than or equal to 16, because that's all the milk you have. Then you're going to have a constraint about flour, so you're going to have to find out how much flour corn muffins need, how much bran muffins need, and it's going to have to be less than 15 because that's all the flour you have. Okay, so I want you to finish the rest of it for homework. So I want you to fill in the numbers, graph it, come up with the vertices, the objective function, etc. Okay? Now, we're going to do one more example to set you up for homework too. So I'm going to work through this example, and then I want you to finish one just like it for homework. So I'm going to stop this for a second and let you guys read this because I'm kind of making this pretty long. So I want you to read through this. So stop my video and read it. Now we're going to set it up. So this is all about airlines and tickets. So first we're going to jump to the main question. In order for Funtime Airways to maximize profit, how many types of each seat should they sell? So the types of each seat is going to be our variables. So we're going to have first class tickets and we're going to have tourist class tickets. And we're trying to maximize profit. So our objective function is going to be all about the profit of these tickets. So first class tickets, they make $24. Tourist class, they make $26. Okay, so now I'm done with those. Now our Constraints are a little bit different here. They have to sell at least 12 first-class tickets and at least 16 class tickets have to be sold. So those are going to be little constraints. So at least 12 first-class tickets, and this is our first-class tickets, so X has to be greater than or equal to 12, because it has to be at least 12, and tourist class has to be at least 16. So Y has to be, if it has to be at least 16, that means it has to be greater than or equal to 16. And then the plane cannot carry more than 50. So if only a total of 50 tickets can be sold, then X plus Y has to be less than or equal to 50. Okay? So now we've taken care of all of the numbers given to us. So now this one actually turns out okay. So we're going to, so we need to look at our scale here. We've got X has to be less than or equal to, greater than or equal to 12. Y has to be greater than or equal to 16. And X plus Y has to be less than or equal to 50. So if we put that in MX plus B, we get Y has to be less than or equal to negative X plus 50. So we've only got 20 spots, 20 boxes, and we need to go to 50. So actually, let's go ahead and do, we can't do 2s, let's do 5s, okay? So we're going to do 5s, and we're going to have to, it's going to be a little tricky, but let's try 5s. So right here, we're going to let this be x-axis, and it stands for first class tickets. And this will be the Y, and it stands for tourist tickets. Okay, so now, and we're counting by 5s. Okay, so first, X greater than or equal to 12. So we're going to count by 5s. We got 5, 10, and then somewhere in here is going to be 12, right? So let's go ahead, and somewhere after the 10, we're going to draw, and I apologize, I can't draw well on here. We're going to go up 12. So this is X equals 12. And it has to be greater than or equal to 12, because we have to sell at least 12 tickets, so we're going to go this way. Okay. Now we want to go, Y has to be greater than or equal to 16. So to 16, counting by 5, so 5, 10, 15. So right above this line is going to be Y equals 16, and it has to be greater than that. Okay. Now we have to do X plus Y, or negative X plus 50. So we're going to count by 5s to 50. So basically going up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our slope is negative 1, so we're just going to go down 1, over 1. And draw that line. And it has to be less than. So our solution set is going to be in here, right? So not too bad, but we're going to have to do some math to find points. So we've got a constraint here that we'll call A. Now, we know, like I said last class, we know all the points on this blue line, the X and the Y have to add up to 50, right? And we know, even though this is not an exact point, we know the X value here is 12, right? Because it's on the X equals 12 line. So if X equals 12, then we can just substitute X equals 12 into this equation, and Y has to equal negative 12 plus 50. So Y has to equal 38. So So let's see if that makes sense here. So 5, 10, 15, 20, 25, 30. Yeah, so that could easily be 38. So now we look at point B here, and we know it is on the y equals 16 line. So we know that y is 16, and there again, it's still on the blue line, so we know that x has to equal, so we know that 16 has to equal negative x plus 50. Right, so if we solve that, it's 50 minus 16, so y is 34. And again, we can check that, 5, 10, 15, 20, 25, 30, so it's above 30, so that makes sense. So we've got A is 12, 38, B is 34, 16, and C is easy because it's in the connection between the x and the y lines. So we know that is 12, 16, because it's on the green line where x equals 12 and the purple line where y equals 16. Okay, so there again, we had to do a little bit of math to find out those points. Now we have our vertices and we can plug them in. So 24x plus 26y is our objective function. So I'm going to stop this real quick and do the math, and you guys do it along with me just to save time because this video is getting too long. Okay, so I stopped the video and did the math, but you guys can stop the video yourselves again and look at it and see how I did it. If you don't understand how I got those numbers, I just plugged in our vertices into our objective function. So now, into our objective function, now again, I'm trying to maximize profit. The highest profit is going to be A. So again, my final answer would be I would make the most money by, I would make the most money so I'll say $1,276 by selling 12, I think that's first class. X is first class, so 12 first class tickets. And 38 tourist class tickets. To maximize profits. Okay. So now, I know I kind of went hurriedly through that, but you can listen to this several times to get the idea. Okay, now for homework, I want you to do the muffin one that we just looked at. Then I want you to do this next slide, which is just another airlines one. So it's very similar to the one we just did. Again, just to get us started, I want your X to be, let's X be business class, just so we're all, there's really no wrong way to do it. But let's let X be business class seats on this one, and Y will be tourist. And that's all I'm going to give you guys for this one. You should be able to do the rest yourself. So take that, so finish that problem. And then also there's one more out of the book I want you to try. Page 185, number 22, and it's about salads. So there again, to get you started, I want your X to be chef salads and Y to be Caesar salads. And this one, just to give you a hint, is going to have like 2 vertical lines and 2 horizontal. So you're going to have like Y greater than something, X greater than something, X less than or equal to something, and Y greater than or equal to some number, and Y less than or equal to some number. Okay? So give these a shot. We'll review them all and go over them in detail on Thursday. So good luck and thanks for listening. Bye.